otherwise, so they may skip the class, not a problem at all. So the salient points that we discussed and we found through those examples was constructors and destructors. These are essential component of our object-oriented class, or when we write a class or structure using object-oriented philosophy. One primary reason is the construction means the allocation of the space for that object, for the object's data members, as well as initializing the elements, because without initialization, even a variable should not, I mean, we don't even start using the variable without initialization. So any variable, and like the variables, any object should be initialized, not only just allocated. So construction is mainly meant for both this process taken together. And to do it, so you can do it writing a separate method, but it can be done automatically. The compiler automatically invokes and executes that construction say function if you rename it in a special way, giving the class name. At the same time, the similar thing can happen if you have written a destructor, so that whatever it has done during creation will be undone during that time. And this is extremely important as a good programming practice. And if you have a pointer member in your pointer variable or pointer constant as your as a part of your member data, this becomes almost essential. Otherwise, you will leave a lot of garbage in the heap, which will not be utilized, which cannot be utilized by your process or program. Okay, so this is important. So even if you don't have anything, you just write it and leave it as blank. And to make sure that it is working properly or not, you add suitable say comments, the suitable display messages to know that which particular copy of the constructor is getting invoked. So while you check the constructors, and we generally, when we write constructors, we tend to overload the constructors so that the user of your class will get a wide range of flexibility. Like in case of stack, we found that one can create a stack object without passing any arguments, where the class designer has assumed that, okay, if you don't specify anything, I'll create a array of at most size say 10. Okay, now if you specify some value, it will consider that to be the size of the max size of the stack that you are trying to design. If you input two values, then apart from allocating the space, as you mentioned, it will probably, the second argument it will consider to be the first element to be inserted in the stack trivially. So in that way, you can have wide range of flexibility if you have overloaded constructors. But for destructors, you cannot overload, because destructors neither accept any argument nor it returns any arguments. So these are few things we found. And if as a designer you have not specified any constructors, still object construction will take place, as we already know that. So in that case, what happens, even though we don't recognize or we don't realize it, but a default constructor gets invoked. So still there is a constructor, and that we call it as a default constructor. And this default constructor, obviously, it cannot perform both the activities a constructor is expected to do. So it will only allocate the space for the data members, but no question of initialization, because you have not written any procedure for that explicitly. So default constructor is always there. But if you write at least one copy of the constructor, even though you don't overload, so whenever you write a copy, so the default constructor will not be provided by the compiler. Okay, so those are the few things that we noted. So in this particular class, we'll be discussing about a special pointer and a special constructor. So special means, so we'll see what kind of speciality it is. So till now we have talked about pointers enough, and also we have talked about constructors in more details. Okay, so let us consider this example. So we are writing a kind of dummy class XYZ, and where all its members, data as well as methods, are treated to be public. Okay, so we tag it as public, and then as per the good practice, we include a constructor. Constructor never returns any values, and let us assume that it accepts some integer variable, and we consider just one constructor only. Okay, so there is no overloaded case. Let us make it simple right now. So whatever you pass will be assigned to X, and we have got another function, say fn, which is having say int b, which also accepts a integer b, and okay, so this is so X is incremented by b. That is the case. And in the display function, which accepts void, so this also returns void. So any normal methods, you should specify what is the return type explicitly, excepting here the constructors do not have any such things. Okay, so see out this, and so that's the end of the class. And we have got another integer X equals to say 10. So this is global. So this is a member function. This is a member data X. Okay, and so within main, we are creating an instance of this particular class. Say let it be M5, and also I'm trying to create something like N, and then I would like to call M dot Fn, say 3. Okay, and then I have got M dot display. Okay, so can you tell me if the code is correct?
No.
No, sir.
Okay, so what is the problem? Where lies the problem?
Zero
XYZ
argument constructor is not given.
See, so this part of the code is fine, right? The class definition, is there any problem here? This is a constructor. This is a normal method. This is another normal method, right? And we are trying to create an object M by passing the value 5. Will it work?
Yes, sir.
So first of all, you have to find out if there are any constructors defined. There is a constructor defined, right? So once there is a constructor defined, the compiler says that at least the compiler is relieved from invoking the default constructor, because once you have done something, the compiler knows that you know how to write constructors. So no default or something as free will be provided to you, right? So it is there. So no default case. So now what it says that m is to be constructed with the value 5, one integer value, accepting one integer. So it has got a matching copy, right? So this is a constructor, so it will be called and it will be created. Now it wants to create xyz n. What is going to happen? Now it says that you are trying to create an object without passing any argument, nor an integer, nor a float, like that. Without passing anything, can you create an object?
No.
Hello?
So here not possible.
So here what is our intention is to create n, construct n without passing any argument. So definitely objects are constructed using constructors always, but here there is a copy of only this constructor, and I mean this particular constructor, and which always accepts one integer. And in fact, once it is there, the compiler will not provide you the default constructor also. Default constructor, how it works, without accepting any arguments, it can construct the object. At least it can allocate the space for n, but that will not trigger here, right? Because we have already written an explicit constructor. Is that point clear?
Yes, sir.
Yes, sir.
So this will not be allowed. So no default constructor is allowed as an explicit constructor is there, right? It is there found. So you cannot write such things in such way. You cannot create. Now I write m.fn3. Will it be allowed? Will it work?
Yes,
M is an
yes,
object.
sir.
It is trying to invoke a fn as a normal method. So fn, is it public? It is public, because anything that follows here is public. All these members are public. So fn is public. So this is allowed, right? And 3 means, so b gets the value 3, it gets added. What is the value of x then?
5.
X will be 5
8.
and 8, right? So now if I would like to write cout x, what do you get? What will be displayed?
8. 8.
Everybody agrees? Now if I would like to display the value of this x, what should I write? The global x?
Scope resolution X.
Can you all recall? So it is always true that whenever you have a particular variable, particular variable name with a global scope, which is globally declared, you can always refer to that, can access that using the scope resolution. Is that part okay?
Yes, sir.
So this will provide you the value 10. So no matter what you do, whatever you have done, so scope resolution x means it will provide you the global value of x. And if you don't have a global copy, it will give an error message. And this x means automatically it will be considered, it will be considering your member data that you have got. And there is ambiguity, as you can see. There is a member data named x, there is a global copy named x. So within the class, if you write x, it will always refer to its member data. And in presence of that member data x, if you would like to refer to the global copy, you have to write scope resolution. That is fine, right? Up to this, is it okay?
Yes, sir.
So what would have happened if so maybe my intention is to, so intentionally, if I write this also as x, that means what? This function fn, what is this x? This x belongs to the function fn, right? It is only within the scope of that method fn. Is that correct?
Yes, sir.
So what is this? So this is within a local scope of fn. So now we have got three definitions of three cases, three cases where the name x has been used. Now first of all, can you do this? Will it not create ambiguity that you have got a member data x and within the function also you have got a x? First of all, is it possible? Is the question clear? This is the first one, right? Make it like this. So this is the first case. A x appears globally. This is a second case. The same name x appears as a member data. And this is a third case. The same name x appears only in the local scope of function. So this x is in the scope of the entire class. This x, third x, is within the scope of this function, and this x is in the global scope. First of all, in presence of 1 and 2, is 3 allowed?
No, sir. No.
Have you ever tried this?
Yes, sir.
Others? Will it be allowed?
So not sure.
Anybody who says possible?
It's allowed, sir.
Hmm?
It is allowed.
It is allowed. So if it is allowed, then how you? So if you write here x, then what it means?
Local scope.
Local.
So now the thing is, if somebody says that it is allowed, then you have got 3x. So if you just write x, which particular x it will refer? Number 1, number 2, or number 3?
Number 3.
What do you think should be there? Now you are in trouble. So you say that the function, within the function you are referring the name x, and apart from the function, the class also has got an x, right? So you know that, okay, global cannot be accessed. That is fine. But which x2 or 3 will be referred if you write here x? Is my question clear?
Yes, sir.
Either it will not be allowed because there is a name clash, or if it is allowed, then how you distinguish the clash, right?
So there is
If
a
I
error.
allow this, see, if I allow this, so then I should have some mechanism to refer to this copy of this second x and a copy of the third x separately, right? Only then it is allowed. So then how it is to be done?
Using this pointer.
Using this pointer.
So first of all, in presence of this x, you see, in presence of this third x, local copy of x, if I write here just x, what do you expect? What will be the output here? What will be the output? If you have got anything to your innermost scope, that will always be referred. Okay, so what do you expect here?
3.
Because you see, this x got the value of this 3, right? This x got the value of this 3. So this will be 3. This is expected to be 3. Hopefully it will be 3, right? Is that fine?
Yes, sir.
And this will be the global x, that is 10. Now in addition to these two, so this means this is referring to the third copy. The third version, or this number 3x. This is referring to the number 1x. So I would like to refer to the number 2x also. So if it is allowed, there should be some mechanism to specify that also. How to do that? How to refer to the number 2x?
This dot X.
This X.
This dot X.
This arrow.
No, not this dot. How can? Anyway, so can you see this name? THIS in small arrow X. So many of you answered this because so those who answered, they know the answer. I mean, they have used maybe somewhere THIS this. So that's why I'm answering. So the rest you will know it in a few moments. So that's not a big issue. So from this, so if this is allowed, so this let us assume that this will be allowed. Let us accept that it will be allowed. I will check it. So if this arrow X, what you are supposed to have? What you are supposed to get in a display? Number
5.
2X.
5.
What
Member
value is
data.
storing? This X, member data X, after this execution, what is it storing?
5.
Why 5? Okay.
Sir, X is equal to X plus will
Okay, yeah.
not execute.
So now this X, you see this particular X is a local copy, and this X. So because whenever you write here X, it means a local copy, right? So nothing gets changed here. So what was the value here of the original X? It was, what is the original value of X? It was this member
5.
data. It was 5.
5.
Hopefully it will be 5. Let us assume. Okay, we'll check it. So before I try all this now, why it is like this? So first of all, what is this? THIS, I mentioned THIS, and the syntax is THIS arrow X. So if you use an arrow, when do you use arrow? So when I use an arrow and I am referring to this X, what is X? X is a member data. So when I am referring to a member data using an arrow, something that appears here must be a, what it should be?
A pointer.
It should be a pointer, right? So if I am mentioning here THIS, so if I write here, if I allow of this syntax is allowed, so this is definitely a pointer. At least without knowing anything, can you guarantee this, that this is going to be a pointer? THIS is a pointer. Do you accept this?
Yes, sir.
So this is a pointer. So I write this is a pointer. So this is a pointer, but to whom it actually points to? Whom it actually points to?
The current
The
object.
current object.
Because you see X means whose X it is referring. So you see this is M. So M is the object, right? So M actually invoked. So M is the object which invoked this function, this method, right? And this X should be this M object's X. Is that fine? Is that okay?
Yes, sir.
So
Yes,
this is
sir.
a pointer to what we can write. This is a pointer pointing to,
Object.
what should I write? Pointing
Object.
to the object. So, which invoked the member method, because we are trying to use this where within this function fn, right? So function fn is a member method, and within that function fn you are trying to use this special pointer this, and through that you are referring to the members of the object m. You are referring to the object m, uh, object m's data space, right? So this is a pointer which definitely should be pointing to the object which invoked the member method. within which we are trying to use this. Are you convinced with this? Logically, is there any clash? I mean, do you accept the statement?
Yes, sir.
So without knowing anything, at least you have to accept that this will work. THISX will work. So if THISX will work, then what is this? This must be a pointer for sure, because otherwise this arrow operator will not work. If it is a pointer, so it should be pointing to whom? To the object which has invoked it, right? Now, so that means if I write XYZ, say P of say 8, and if I invoke P dot Fn say 12. Okay, so when P dot Fn is invoked, and again it will be called, so in that case, this will be pointing to whom? The
P.
same this pointer
P.
will be pointing to this object P, which has invoked this method. When this m dot Fn is called, the same THIS, this pointer will be pointing to whom? This object M, which has invoked the method Fn. Is that part clear? Is that
Yes,
part
sir.
clear? So this is basically a pointer variable, because you know when P dot Fn is called, THIS, this is pointing to the object P's base address. When this m dot Fn is called, this pointer, this is pointing to the object M's base address. So it is pointing to sometimes this object, sometimes that object, like that. So it is indeed it's not a pointer constant, it's a pointer variable capable of pointing to objects, or it actually points to the objects which invokes the methods. But is there any mention there? So where it is declared? So how? So is it automatically appearing? Where it is there? It is not found here, right? Can you see the presence of this? Is this found here anywhere? Hmm? Can we see the this anywhere in the local arguments?
No, sir.
Where from it pops up? I mean, somebody need to write this, right? Somewhere it need to be there. Where from it is obtained? See, actually what happens, so when you actually write this, okay, so this m dot Fn, when it is called something like this, m dot Fn, then instead of passing one argument, it passes the address of m and then 3. Got the change? So this is the something the compiler silently does. Got the point? So originally the function, in the method, how many arguments are there? One argument, integer argument. But during compilation, what it does, it converts it into 2 arguments. What is the first argument? In the first argument, it passes the, what is this? Ampersand n means it passes the
Address of L.
address of the object itself. So this nothing is by magic. So it is actually done, but it appears to you that there is no this declared anywhere here or here, and it starts working. So the fact is, during compilation, you can easily write a piece of code where any method call will be translated to uh, something like this, where one more additional argument is added in the beginning of the argument list. Is that part clear? Hello?
Yes, sir.
So if you are calling a member method with three arguments, you know that after the post compilation, it will have actually 4 arguments, because the first argument should always be what? The address of the object which invokes it. And who does this kind of translation, this kind of modification? The compiler does it. And the compiler does it almost for all types of methods. There are some exclusions. So we'll talk about it later on. So is that part clear?
Yes.
So now, so let us click 3. So now what happens? So to facilitate this, or if this happens, so there should be some translation in the function body also, right? Where we are defining the function. That means this function will appear something like this: void fn. There should be some change. What is that? How it should appear?
There will be a pointer. This
Pointer to XYZ.
So it should be, because we have to accommodate the address of this object also. Who should store it? There should be some pointer. What is that pointer name?
this
This.
That is this pointer. Okay. So there is no const keyword here, right? So this is a pointer, just a pointer. This is a pointer variable. Pointing to what? Pointing to
XYZ.
XYZ.
XYZ, right? And then what is the second argument? It is as it is the intx that we have actually done. Got the change? So these are the internal changes or internal modifications that the compiler makes to make it abstract, appear to be magical, and this abstraction is done by the object-oriented compiler. So the object-oriented compiler is nothing too much difficult, but these are the things that appears, that makes things at the first glance you will find that something magical is happening. So you have not written anywhere this, but this works. So, but actually the compiler has done it for you. If you would have, it would have been able. I mean, you are able to decode that or read after the post compilation. You would have found something like this in the calling and something like this in the body of the function. And once this is there, now you know that there is no magic. So you are, so it has silently inserted this pointer in all the methods. In fact, here also it will add that, right? So here also the same thing will be added, and it will be right void display again xyz asterisk this int sorry asterisk this. So how many arguments post compilation this display function will have after compilation? Originally the display function is having how many arguments?
0.
0 argument.
0 arguments. So if it is 0 arguments, now after compilation it will have just 1, because that is always added. That is the address of the object which invokes it. So here also it will be asterisk this. Got the case? So this will be, so this the function body, the prototype will be replaced by this, and here also it will be replaced by this. Here also it will be translated by this. Here also it will be translated by this. So in the second case, what will happen? Again, it will be p.fn m, 12. Is that part clear?
So can we change the value of this, because const is not given in the definition?
What do you think? Good
It
question.
should not be.
What do you think? I'll come to it later. I mean, okay, so you have raised the question.
No.
So up to this part is clear. So what I mentioned, so this is a pointer. This is a pointer variable. That is fine. To the object which it invokes as a member method. Now the thing is, a pointer variable means it can point to sometimes this person, sometimes that person, like that. So here, if you write this plus plus, what will happen? If you write this plus plus means what? What do you expect? If there is an array of objects, this is pointing to the object 2. If you write this plus plus, what does it mean? This will point to
The
Object
next object.
second object, like that. So what do you think? Will it be allowed?
No, sir.
Will it be allowed?
No.
But if I would like to, but you see, if I would like to do something like this, uh, or here, it became too clumsy. Anyway, let me try here. So this x plus equals to say plus equals to 5, I write. That is fine. So this x means what? This x means this local x. If I would like to update this member x also, what should I write? This arrow x plus equal to x. That is possible. This statement, this particular statement means it is updating this local variable x. This particular statement means it is updating this member copy x. So what do you think? So the first thing is you cannot write it of your own, right? So you as a coder, you cannot modify this. So these are done automatically by the compiler. These are done automatically by the compiler. But at this moment, because this should always point to the object which has invoked it, which has invoked the method. So should it point to something else? So will it be possible that you can write here this plus plus? Will it be allowed?
No, sir.
To stop this happen, how should this definition should be modified? So what should be the true declaration of this while the translation takes place?
Const pointer.
Const pointer.
So const keyword, where it should be inserted?
After the asterisk.
Yes.
Where?
After the asterisk.
After the
After
asterisk.
the asterisk.
So it should be here added, right? Here, right here. It should be right here. That means this should be treated as a constant pointer pointing to some objects. And so this is, so at least for this time being, so when you have called the function, this will not be able to change whatever it points to, but the contents of the location can be changed, right? So the object space that it points to, its members can be changed, right? Are you getting the point? That this pointer is pointing to some object, and during that method invocation, method execution, this pointer cannot point to some other objects. That is fine. But using the arrow operator or whatever, you can change the contents of the members of that object. So to whatever it points to is not constant, but this itself is treated as a constant. So what should be the true definition of this pointer? It should be const. This becomes too clumsy. Is that fine? Is that okay?
Yes, sir.
So here it should be const this, and whether it is so probably it is this. And how to make sure that it is this? You can just write this plus plus within that member method. If it is allowed, you know that there is no const keyword. If it is not allowed, you know that there is definitely a const keyword which has been used by the compiler while such kind of translation is going on, or whenever the code is getting modified by the compiler. Is that fine?
Yes, sir.
So now let us try to check this, how it works. I think this was the it becomes difficult to modify. Anyway. Okay, so this is pp, this is index, and we have int x equals to 10, the global copy, and we have got maybe one constructor and a trivial destructor, the display function, or let it be that fn accepts an integer, read da first, and then this is not there. Let it be just int a. So now I am modifying x plus equal to a. This is no, this is just x equals to a, constructor initialized x. This was the constructor, this gets removed. This was the destructor, it's removed. Okay, then comes actual function fn, which requires an integer value, which is a. We are updating the values, value of x plus equal to a. Okay, then we are displaying here x, then scope resolution x. Is that okay? This is not required. So it's one dot say 10, and we have s1 dot fn. Fn also accepts some value 5, and there is no display here. Is the code correct? Yes, it is correct. Let's see. So constructor initialized, constructor initialized 10, and then what it displays? Then 15 and 10. So 15, whose value is 15? Okay, can you see now here? So when I invoke this fn, so fn has got two values to display. One is this x, normal x. Normal x means which one it will refer? Which one it will refer in normal x?
The local x to the function.
This member data x, right? So let us call it as 2, as we earlier mentioned. And this is, say, this is a global. Let us call it as 1. Okay. So the global one remains. The global one remains as 10. You see, the second one is scope resolution X, that is 10, and the first one got modified to 15 because we have constructed with value 10, and then you are adding 5 to it. Okay, so this is the case. So now let us try to modify it that this becomes X. First of all, let us see if this is allowed or not. A is not declared. What is that? Okay. So let us do it plus plus. So plus plus means what? The value of X will be just incremented, whatever is the value. First of all, this is allowed. Got this point? Can you all
Yes.
see? So this is,
Yes, sir.
this is, let us call it as a third case. So that case 3. So this is the local X, local to function, local to the method. So see, you have got the coexistence of the global copy, the member copy, as well as the local copy. So these three copies coexist. Fine. So now if you write here X, normal X, what it means? It will always refer to its innermost scope, the immediate scope. It is a local copy. What is the local copy? So you have actually, I have actually passed here 5. So 5 gets copied to this X, and that X gets incremented. So 5 to 6. So that's why this 6 gets displayed here. Is that fine?
Yes, sir.
And
Yes,
the
sir.
10 is actually the global copy. So there is no modification that you can make through this onto the second copy, the member copy. And the member copy, how you can access it? If you write here, how can I refer to the member copy also? This can be through this.
Yes.
So what we can write here? PHIS arrow X. Is that fine? Now what do you expect? What output do you expect?
So 6, 10, and 5.
Just to make it a bit more clear, let us make it 20. The member copy will be 20 because you are not making any change in the member copy. So its original value will be displayed. Got it? So this is a local copy which is incremented. This is the global copy which was 10, and this is a member copy which was initialized to 20 and no change was made there, right? So you found that
Sir.
these three, yes.
Sir, we have a class from 11.
Yeah, just I'll complete the class. So is that fine? So local copy, the global copy, and this one. So if I would like to change, if I would like to make a change in this in the member copy, so PHIS, just 1 minute. PHIS, I can write here plus equal to X. Will it work? PHIS equal to PHIS X plus X. PHIS X equal. Got it? Hello?
Yes, sir.
Yes, sir.
Okay. So now, so you know that is now the thing is one last point. that will end the class. So this plus plus. If I write this plus plus, then what is going to happen? Let's see.
Error.
Will it allow increment
sir.
of read-only location? Because this this is actually L value required, so you cannot do that. So that means, so this proves that this is treated as a pointer constant, not as a pointer variable. Is that okay?
Yes, sir.
Okay, I should have completed it a bit early. So in the next class, I'll be talking about the use of this pointer, and there are very nice examples of how to use it in a nice way. Okay, I'm leaving.
Thank you, sir.
Thank you, sir.